inversely proportional. So let's start by looking at direct, and we're going to go over some theory and see what that actually looks like mathematically. So apart from knowing that things that are directly proportional are kind of related to each other in some way, we can actually draw what it would look like on a graph. So for things to be directly proportional, they have to be a straight line, has to go through the origin, so that point there. Okay, so that is, if things are directly proportional, they have to be lines that go through that, like that, or we could have one like this, this, this. So first thing to note is, we know the equation of a line is y mx plus c. But we're looking at this line specifically, or lines like this, any line that goes through the origin. And going through the origin means it crosses the y-axis at 0. So that means c is 0. So things that are directly proportional have the form, so the equation of the line is y equals mx. However, for proportion, we kind of write it differently. We write y equals big AX. It means exactly the same thing. So that's what the formula looks like for things that are directly proportional. You just have a different value of A. So A is going to determine the steepness, the gradient. So if the line looks like that, that. So A is what we're always looking for. So I'm going to write out a question now in which we can see this graph in action. Okay, so this is question number 1, our example. So the fuel F in litres, so I forgot to write that down, an aeroplane uses is directly proportional to the distance that it travels. That kind of makes sense. It's like a train, like a car. The further you travel, the more fuel you have to buy. And we're talking about distance in kilometres. The aeroplane used 200 litres of fuel on a 5,000 kilometre journey. Write down the equation F equals AD. So basically what this is telling us to find, it's kind of saying find A and then write it in this form. Please note these numbers are extremely random and may not work, but we're going to work with it. So we know that it has to be in this form, which is the form it's given us here. So we could do a little, do a little sketch of the graph. So we're going to have Y in this case is F, so the fuel in litres. And then we're going to have along the x-axis distance D. So what that's going to look like, we're not entirely sure yet, but it's going to be something that goes through here and a line a bit like that. So we're trying to find the gradient or the A. So we've kind of been given a point on this graph in a way. So it's told us that it's used 200 litres for 5,000 kilometres. So we could say that could be that point there. So how far has it gone in distance? 5,000, and how many litres? 200. So it's kind of given us a point on the line. So now we have everything we need to work this out. So that's what it would look like. You don't necessarily need that sketch. So let's put the stuff in, the numbers. So F equals AD, fad. We know how much fuel it's used, and that is 200 litres. We're looking for A, and we know it's multiplied by the distance, which it's gone, is 5,000 kilometres. So to find A, we rearrange this. We do 200, multiply on this side, so it becomes divide on this side by 5,000. So first of all, we can get rid of 2 of the zeros, cancel those out. So we know that A is 2 over 50, or 1 over 25. So now we've found A. It says write down the equation in this form. So we haven't finished, we just literally need to put everything we've just worked out into one place. The equation is going to be F equals, instead of A this time, 1 over 25 D. Okay, so example number 1. So if it costs 75p to buy 5 bananas, how much does it cost to buy 7 bananas? So this is exactly like the method I used for unit conversions in that video. So we're going to run over that type of way and do all that way basically. So the way I like to do this is a column method. So I put bananas over here, so I have 5 bananas. And the money, so that cost me 0.75. Now we need to work out a rule to get from this side to this side. So the way I do that is I always want to start with a 1 in this column. So to get a 1 in this column, I'm starting at 5 bananas, but I want 1 banana. So to get from 5 to 1, I divide by 5. And that is because 5 divided by 5 is the same as 5 over 5, which cancels to give me 1. But if I've done it on this side, I need to do it on this side. So I also divide this column by 5. So I do 75p divided by 5, which should give me 15 pence. Okay, this is the stage we want to be at because this is when we can use the rule. So I know to get from here, to get from 1 to 0.15, I multiply by 0.15. I just multiply by this number here. If I was working the other way, if I started with money and I wanted to go this way, I'd do the inverse operation and I would divide by 0.15. So what am I looking for? I want 7 bananas, and I'm going this way, so I follow this arrow here and I multiply by 0.15, and that gives me the answer £1.05. Okay, so that's how we do it. We aim for this. I always use this column method, which I think is really nice. You always start with 1 to work out your rule, and then you put all your information in the column. So we'll do another example, because it's always hard the first time you see it. Okay, so we have 500 sheets of paper weigh 2.5 kilograms. How much does 50 sheets weigh? So we do the column method. So we've got 500 sheets over here, so in our sheets column, and we have the weight 2.5 kg. So first of all, we want to know how much one sheet weighs. We always want to get this 1 here. So to get from 500 to 1, I have to divide by 500. If I've done that on this side, I have to do the same on this side. So I divide that by 500, which gives me the answer 0.005. Just going to ignore the units for now. I'm not asked for how much one sheet weighs, though. I'm asked for how much 50 sheets weigh. So I scale that up. So I actually want 50 in here. So what have I done to the 1? I've multiplied by 50. So I do that on this side, and I multiply by 50, and that should give me an answer of 0.25, so you know it weighs 0.25 kilograms. Okay, so here I have 2 chocolate bars. So this one cost me £1 and it's 135 grams. Again, I'm making the price up, I don't remember how much it cost me. And this one costs £1.50 and it's 200 gram bar. So we've got Sainsbury's dark, or we've got this Co-op dark. Now, I want to work out which one is best value for money. So, as you can see, this topic is going to be very useful when shopping in a supermarket and trying to sort your life out and get the bargains. So, it's worth paying attention. What I do here is, I know it's £1 for 135 grams and £1.50 for 200 grams. So I'm going to work out how much each one costs. Sorry, this is open. How many grams I get for 1 penny. So you work out per penny so this is Best Buy. This is no longer an exam question. This is just me having fun. So Best Buy question, these are called. So it's 135 grams for £1. So I do 135, that's grams, divided by, and that's 100 pennies, because there's 100 pennies in a pound. So that means I get 1.35 grams per penny. Okay, so for every penny I pay, I'm getting 1 gram, 0.35. What about my Sainsbury's bar? So I have 200 grams this time, and I'm paying 150 no, I'm not, jeez. £1.50, so that's 150 pennies. So if I do that calculation, I end up with 1.3 recurring grams per penny. So which one do I get more per penny? So basically which value is higher. So I'm getting more in this Co-op chocolate bar per penny, only like by a very, very small amount, but that means the Co-op one is the best buy, because I get more per penny. So you have to basically get them to a scale. So these are different prices. You kind of have to get them to a value that you can actually compare. Okay, part 2, we're looking at inversely proportional. And again, let's sketch a graph and see what that would actually look like. So inversely proportional looks like this. That means as one goes up, the other value goes down. So as we can see, x going up here, so x is getting higher and higher, but y is getting smaller and smaller, and here x is getting smaller and smaller and smaller, almost zero, and y is getting bigger and bigger and bigger. So it does the opposite. And previously, the directly proportional was this equation here, which we looked at from an equation of a line. But the inversely proportional works like this. You get y equals a over x. So that's now the formula for inversely proportional, and that's what it looks like. As one goes up, one goes down. Okay, it takes 3 bakers 10 hours to produce a wedding cake. How long would it take 6 bakers and then to produce a wedding cake? Okay, so the way inversely proportional works is you find out, again, with the directly proportional, we were looking for the value of 1 and then scaling it up. So we're kind of going to do the same thing here. So it's saying it takes 3 bakers 10 hours to produce a wedding cake. So how long would it take 1 baker? So if it takes 3 bakers 10 hours, it's going to be 10 hours, but instead of splitting the work between 3 of you, you have to do the 3 people's work times 3. So you've got 3 bakers working for 10 hours, so if you're 1 baker, you need to do all that time by yourself. So that's going to take you 30 hours if you're 1 baker. However, we have 6 bakers, so it's going to take 6 bakers less time than it's going to take 1 baker. So what you do is you divide the time that it takes 1 person by 6. So if it takes 30 hours for 1 person, you divide that by 6 because there's 6 bakers working on this cake, and that means you do 5. It's going to take 5 hours for the 6 of you to make a cake. So it kind of makes sense because it's going to take 1 person longer than it's going to take 6 people, unless you keep arguing. Okay, so it takes 3 painters 6 days to complete the work. How long would it take 2 painters? Some questions are kind of annoying, so they don't really break the steps down for you. So forget how long it would take 2 painters. The question you ask yourself first is how long would it take 1 painter? So how do we work that out? So we know it takes 3 painters 6 days. So it was going to take 3 6 days, but you're only 1. It's going to take you 3 times as long. So it's going to be 6 times 3. So it's going to take you 18 days if you're just working alone because you don't have 2 other people to do some work. So we know it takes 1 painter 18 days, but the question is actually asking you how long would it take 2 painters, so you've got help. So you're splitting the work by 2. So it's going to take 18 days for 1 person to do it, so it's going to take 18 divided by 2 if you're all working nice and evenly. 9 days for 2 painters. So they all the questions follow this very similar pattern. Work out how long it's going to take 1 person to do the job, and then divide by however many people you have doing the job.